In this unit, we will learn about radian measure in coterminal angles. In geometry, we always measured angles between 0 and 180 degrees, but in trigonometry, we can measure any angle, even negative angles. In order to do this, we must place the angle on the Cartesian coordinate system. To do this, place the vertex of the angle at the origin and place one of the rays of the angle on the x-axis. The side of the angle placed on the x-axis is known as the initial side, and the other side of the angle is known as the terminal side. The angle is measured by the amount of rotation from the initial side to the terminal side. If the angle is measured in a counterclockwise direction, the measurement is positive, and in this case, it is 45 degrees. If the angle is measured in a clockwise direction, the measurement is negative. In this case, it is negative 315 degrees. Angles can also be measured in more than one full rotation of 360 degrees. In this case, from the initial side all the way around the graph through the initial side to the terminal side again would result in 405 degrees. The measurement of 45 degrees, negative 315 degrees, and 405 degrees all result in the exact same angle. Therefore, they are called coterminal angles. Up until this point in mathematics, all angles have been measured in degrees. But degrees is not the standard unit for measuring angles. Radians are. So that begs the question, what is a radian? Imagine making a circle on a Cartesian graph. The radius of that circle would then be extended upward and curved around the circle itself. The arc that it creates would have a central angle measurement of 1 radian. Here you can see an angle on a Cartesian graph with a measurement of 1 radian. If converted back to degrees, 1 radian is approximately 57.296 degrees. Continuing to work our way around the circle, 2 radians is approximately 115 degrees, 3 radians is approximately 172 degrees, 4 radians is approximately 229 degrees, 5 radians is approximately 286 degrees, and 6 radians is 344 degrees. The problem is none of these numbers are particularly interesting. For this reason, angles are rarely measured in radians using whole numbers. Let's look a little closer at this semicircle measured in radians. I already told you that 3 radians is approximately 172 degrees, but you can see the diameter of this circle is just a little bit more than 3 radians. Actually, it's approximately 3.141592654 radians. That's right, half of a circle is pi radians. So radians are most commonly measured in terms of pi. So in terms of pi, 180 degrees would be pi radians. 90 degrees would it be half of that. So half of pi radians is pi over 2 radians. 45 degrees is halfway between 0 and 90 degrees, so that would be pi over 4 radians. And one full rotation of 360 degrees will be 2 pi radians. So now we ask the question, how do you convert degrees to radians? We know from our previous example that 180 degrees is pi radians. And we can use this as a conversion factor to convert any degree measure of an angle into radians. Simply by multiplying the angle measure in degrees by pi over 180 degrees. and the pi on top is expressed in radians. So if we want to convert 90 degrees into radians, we multiply that by pi over 180. And remember, the top's radians and the bottom's degrees. And 90 degrees would just be over 1. You multiply straight across. 90 degrees times pi radians divided by 180 degrees. Now we have 90 degrees on top and 180 degrees on the bottom, so we can reduce that to 1/2. But also, the degrees on top and the degrees on bottom will cancel out themselves. So 1 times pi is pi. 180 was reduced to a 2. 90 degrees is pi over 2 radians. Now, typically when you write it in terms of pi, you don't include the RAD at the end. Since it's the standard unit, it's assumed that it's in radians as soon as you see a pi in the angle measure. Okay, let's try another one. 135 degrees. So we're going to multiply that by pi over 180. And we put over 1. So 135 degrees times pi is just 135 times pi degrees over 180. And now you can reduce 135 and 180 reduced to 3/4. So this is 3 pi over 4 radians. The degrees again canceled because we had degrees in the top and the bottom. So 135 degrees is 3 pi over 4 radians. So how do we convert radians to degrees? Well, we're still going to use the same conversion rate of 180 degrees equals pi radians. But this time we're not going to multiply by pi over 180. We're going to multiply by 180 degrees over pi radians. So if we were to convert pi over 6 radians into degrees, we would multiply that by 180 degrees over pi radians. And this is also expressed in radians. So when we multiply these two together, the pi's will actually cancel out from each other, and the radians will actually cancel out from each other. And we end up with 180 degrees over 6. And that could be simply divided. 6 goes into 180 30 times. So pi over 6 radians is 30 degrees. But what if it's radians, but it's not expressed in terms of pi? Instead, it's just a whole number like we saw originally. So 5 radians, and I'm definitely going to put the RAD next to that one, convert it into degrees. We're going to multiply by 180 degrees over pi radians. So 5 times 180 is 900. And then the pi just gets multiplied by 1 on that side. But the radians are going to drop out. So now we have 900 degrees divided by pi, and 900 divided by 3.14 is approximately 286.479 degrees. Let's go back to coterminal angles for a second. If an angle is expressed in degrees, coterminal angles can be found by adding or subtracting 360 degrees to that angle. If you add 360 degrees to a positive angle, you get the loop around through the initial side back to the terminal side again. And if you subtract 360 degrees from a positive angle, you will get the negative or the clockwise way to get to that terminal side. So we're going to find two coterminal angles to 130 degrees. So we're going to do this by taking 130 degrees and simply adding 360 to it. And that gives you 490 degrees. So 490 degrees and 130 degrees are coterminal. Let's find a negative one. Let's take 130 degrees and subtract 360 degrees from it. So this will give us our clockwise rotation angle, and that is negative 230 degrees. So 130 degrees, 490 degrees, and negative 230 degrees are all coterminal angles. Angles measured in radians also have coterminal angles, and they can be found by adding and subtracting 2 pi to that angle. Remember, 2 pi was 360 degrees. It is a full rotation around a circle. This gets a little bit more tricky because it involves adding and subtracting fractions a lot of times. So if we're going to find two angles coterminal to pi over 2, remember that was 90 degrees, but we're going to keep it in radians for this. We're going to have to add or subtract 2 pi from pi over 2. So pi over 2 plus 2 pi. You can't just simply add those together. You need common denominators. So we're going to have to rewrite 2 pi as something over 2. So we're going to multiply, we're going to put it over 1 for now and multiply the numerator and denominator by 2. So 2 times 2 pi is 4 pi, and 2 times 1 is 2. So instead of adding 2 pi to pi over 2, we're going to add its equivalent fraction, 4 pi over 2, to it. So pi over 2 plus 4 pi over 2. Now that we have common denominators, you can add the numerators to each other. The pi by itself is really 1 pi, so 1 pi plus 4 pi is 5 pi. And the denominators stay as 2. So 5 pi over 2 radians is coterminal to pi over 2 radians. Now let's find a negative one. So we got pi over 2 minus 2 pi. And once again, we're just going to use the 4 pi over 2 as the substitute for 2 pi. So now we have pi over 2 minus 4 pi over 2. 1 pi minus 4 pi is negative 3 pi, and the 2 stay. So negative 3 pi over 2 is coterminal to 5 pi over 2, which is coterminal to pi over 2. They are all the same angle. It's just 3 different ways to write the same angle measurement. So now you're probably asking yourself, why would we use radians over degrees ever? Degrees are really easy to use, and radians involve fractions, and they involve pi, and it just seems much more complicated. But the truth is, there are many equations that are easier to solve if you are using radians as your angle measure, as opposed to degrees. One of those is arc length. To find the formula to find arc length using radians is really simple. It's S, which is the arc length, equals the radius times the angle, as long as the angle is measured in radians. This is a really easy formula. It just has one multiplication part in it. And let's see how it will actually end up working out. So here we have a circle with a radius of 4 inches. And we need to find the length of the arc intercepted by a central angle of 240 degrees. Now, remember, this formula only works if the angle is in radians, so we have to convert 240 degrees into radians. So let's convert. 240 times pi over 180 equals 240, and this is degrees. 240 degrees times pi over 180 degrees. The degrees drops out. The radians stay from the pi. And you can reduce 240 over 180 to 4 pi over 3. So that is 240 degrees expressed in radians. Now we can use our simple equation. The arc length equals the radius times the angle measured in radians. And our radius is 4. And our angle measured in radians is 4 pi over 3. And that 4 times 4 is 16, 16 pi over 3. And on a calculator, you can simplify 16 times pi divided by 3. And that is approximately 16.76. Now, what is our unit? Since our radius was in inches, our arc length is also going to be in inches. And that was a pretty easy formula to use as soon as we had the angle in radians. The area of a sector of a circle is another easy formula as long as your angle is measured in radians. It's the simple equation 1/2 times the radius squared times the angle measure as long as the angle is measured in radians. Now, I'm not going to do an example of this because I want you to do that. So let's look back at Google Classroom and see what our activities are.